Okay. And so just a couple introductory slides. So today we'll be talking about basically our Octavius cluster that we have here at Georgia Tech and integrating that into an OpenOnDemand workflow. So if I go to the next slide. Oh, I cannot go to the next slide. So obviously, A64FX is growing in popularity. I think we saw the great success of Fugaku and then Isambard 2, Ookami. And I think we're going to continue to see a number of ARM clusters rise up. But I think as Jeff was mentioning, as there's more interest in a lot of the tools and such that are associated with it, what about users that want that full interactive workflow where they can submit and run jobs, take advantage of GUI utilities, such as the one we saw in the previous talk, or like the ARM Forge tools, Jupyter notebooks, those types of things, with a lower barrier for entry, right? That's always the key bit. You can sit there and do the tried and true way of SSH tunneling, but especially for new users, that can be kind of a prohibitive experience and represents a challenge that they have to overcome. And so to that effect, we can take advantage of gateways such as OpenOnDemand, which provide this really nice template for web-based experience to be able to do that type of workflow. And so I really have no idea why it's not letting me advance to the next slide. So I guess a little bit about Octavius itself. It's actually part of a larger NSF MRI project for the Hive cluster. So I'm from PACE, which manages kind of the traditional HPC side with the x86 architecture. And then the A64FX component is hosted in CRNCH, where Jeff is. And basically, it was meant to allow HPC users to also evaluate the ARM ecosystem and the SV alternative to the AVX 512 nodes that we have on the Hive side of things, on the PACE side of the Hive cluster. It's hosted in actually a larger collection of novel architectures called the Rogues Gallery that includes a variety of other systems. And that also has its own NSF support through a CCRI grant. So Octavius was deployed in fall of 2012, so right around the same time as Ookami. Also uses HPE's Apollo 80 chassis. And right now, our system is set up with Cray, ARM, the LLVM, GCC compilers, a handful of libraries. Of course, we're continuing to grow that software stack. We'll try and keep it as neat and as exciting as merited by the user base. So with that, what is OpenOnDemand? Maybe you all have seen this. It's not anything too new. It's developed by Ohio Supercomputing Center and various collaborators, and has been in production for several years now. But basically what it does is it sets up Apache web servers and then uses Nginx to basically provide access to these GUIs all through web browser-based interface. And so it integrates nicely with schedulers. We've used it with Torque that we have on PACE side. Here we use it with Slurm. But that way you can just log into the website, you're good to go. You can spin up various apps. So right now, for example, on Octavius, we've got a virtual desktop. We've got the ARM Forge DDT and map suite. And then we've got Jupyter notebooks that we've set up. And for our CRNCH testbed, right, the reason why we chose OpenOnDemand was for its ease of deployment, the integration with Slurm, and the fact that it allows for unique, workflows by the users. Comparatively, on the x86 side of Hive that PACE manages, we actually use a different gateway called Apache Aravada that was kind of set up by the folks at Indiana. And the difference there is that it's more of a templated workflow where basically the applications are fixed and users log in and they run experiments by just providing unique configuration or data input files, but the actual code itself stays static. And so I think, kind of the justification between the two is there's a lot more exploration on the ARM side of things, a lot more interest in trying to figure out new ways to do things and get better libraries and application development. So we wanted to support that. The other thing too is that the pay side of things tends to support a larger number of users, and so doing the external users that you would typically see come in through this Apache Ayurveda framework, the authentication is done offsite, so it kind of takes the onus off of PACE staff to have to vet every user that comes through. So with that being said, what we've actually done today is set up 3 different tutorials, or demos rather. And I guess, I'll backtrack and talk about this, that there were a couple challenges. Obviously, there's a lot of the AHUG-64 ecosystem that is pretty well developed. So most of the applications work very well. There were some nuances in some of the templates. So for example, with Slurm, because the job submission, the controller, and all that are running on the x86, we had to do some sim linking to fix issues with finding the right architecture binaries, but not anything too complicated. OpenOnDemand tends to be templated for a lot of stuff, and so they have a preference for Turbo VNC. So for example, for the RMAP, we had to just kind of hand build some of the stuff because it wasn't available for the appropriate architecture, but it wasn't anything too taxing either. There are obviously some application specific workflows that could be improved upon, that are kind of ubiquitous for research. So for example, we did find that getting efficient TensorFlow, PyTorch, just trying to follow along with the standard release packages, or a couple of the AHUG-64 ones didn't seem to be performing quite as well as we wanted, but I did see in Slack that there's some good discussion there. So of course, that's just a lack of knowledge on our part, I guess, to put the right tools in place. But as more and more applications are stood up and we support it through OD, we would want to do that. Of course, the real meat of this is to focus on OpenOnDemand and what it looks like. And so hopefully y'all can see my browser here, and I apologize, it's a little bit slow. I'm not in the city, so I don't have the fastest internet. But basically, you log in, it authenticates through our single sign-on page, and so you don't have to worry about that, right? It just wraps right into LDAP for authentication, no problem there. You have a file explorer, so you can see all of your files on the cluster as it stands. You can take a look at whatever active jobs are running, just like you would normally want to do. If you wanted to have shell access, now, of course, because this is not Octavius specific, it does log us into this particular server, but once you're in there, you can freely move to like the login node for the Octavius cluster and such. So in case you need to do anything from the command line, it works pretty nicely that way. But the real juice lies in the interactive apps. And so the 3 that we've set up so far are this CRNCH desktop, which basically just starts a VNC session and then opens it up here in the browser. You'd specify the number of hours you want your job to run, the nodes, what partition you want it to run on. And of course, this is good. We see a lot of our users use it for software that doesn't have a better hook set up to run it through like a direct connection. The ARMForge, actually, Ohio Supercomputing had a really good template for this that we were able to basically apply, and just had to do some minor modifications to support for the Octavius. Like I said, I think the Turbo VNC building those custom backends was the important part. Basically, again, you just give the job options. You can configure what the forms look like. And then Jupyter Notebook. And what's nice about this is that you can actually set up templated workflows to basically help users onboard and quickly run things. And so what I've done before I started this was actually spin up a couple interactive sessions. So once you submit the job, it pulls up a page like this, and you'll see when it's available to start running. And to connect to it, you just click connect, and it immediately goes and it opens up whatever application it is that you're trying to run. And so here, as an example of how we could integrate this in, I actually borrowed John Linford's really, really nice RMSV tools repo. I did fork it to something personal because there's some modifications to the config.make and the various make files. But what we can do is just basically run through and do the entire workflow in the scope of a Jupyter notebook, and just basically take advantage of some nice bash magics to run it, loop over the different compiler options that you'd be interested in, and then tee in the output, just doing some stream redirection basically to print everything that would normally happen when you run that loop to standard out. So it'll come down here in the cell and display. Takes like, I think, 50 seconds or so to run. But then it dumps everything into a variable that's accessible within the Python scope of the rest of the notebook. And so this way, we can kind of have this really nice tutorial where we're running things in that Bash native framework, allowing users to basically look and say, okay, this is what happens. We get all these nice reports on vectorization. And it, each step of the way when it runs, it gives the report. And then this line here basically tees it to standard error, parses that to basically extract the number for each one, and then dumps it into a new line delimited string in the variable naive, which we can then go and say, okay, let's put that into a pandas data frame and get a nice little table. If we want to make a bar plot of the results, we can also do that. And so, I think this is kind of the direction that we're liking to see to try and onboard new users, expose them to the different compiler or library options that are available to them, how to tweak things, how to run it a little bit more effectively on the new one. That way we can get more researchers involved in this, especially at GT, in terms of looking into designing new applications or refining old ones to better run on this type of platform. So that's the first demo that I have. And then the next one here is the tried and true DDT and map. And so again, what this does is this runs it through a VNC session. Well, specifically, it's using no VNC as the backend, but putting it here in the browser. And it works just like the regular GUI. So I can go and I can say, okay, I want to profile a program. I could take my really badly compiled XHPCG. That's just using, I think like the system GCC. And I can tell it, okay, go ahead and run this. Why don't we go ahead, we can put it on all 48 threads, because why not? And we let it run for some amount of time. Obviously, this is extremely inefficient, so that's not the purpose of this. So please forgive me for the bad performance here. I know everyone else is talking about highly tailored algorithms. That is not what this is. This is meant more just to demonstrate making a tool like this much more accessible in the graphical format. Let's stop. It goes and does its thing, and then it generates the port really, really nicely. And so this way, it makes these tools just a much lower level of knowledge needed to access them, because and also less resource requirements, right? I know running workshops I've encountered where I have people who come and say, oh, well, this is actually my work laptop and I don't have system privileges, so how do I get this? I'm going to have to have PuTTY, and then it turns out, oh, well, they actually blocked all ports through a firewall and I don't have permissions to change it, right? This is just a standard web portal. You can run this on your iPad, you can run this on your smartphone if you've got enough juice, and it just works, right? So it's really, really nice and powerful in that sense, and just kind of opens up the gates in terms of what people can do. And so with that, actually, I'll hand it over to Jeff Valdez, who is also with Georgia Tech, I believe it's interactive computing, and he'll demo the last set of notebooks.
Great, thank you, Aaron. Let me just see if I can share a screen here.
Now, I'll note while just switching over that all of these demos are running live on our A64FX nodes. So I think that's what makes it really interesting to me.
Right, and thanks, Jeff, and thanks, Aaron. So as Aaron was describing, this is the third example that we have is to try to run kind of machine learning or AI type of pipelines as well. And here, Kevin had set up kind of these containers, these to show examples of TensorFlow and PyTorch, which are common in AI and machine learning. So here, this is a Jupyter notebook that uses Singularity to spin up a container. In this case, we just use kind of a standard TensorFlow implementation here, which is this is just a comparison between CPU and GPU. And obviously, we're just trying to demonstrate the ARM CPU architecture today. So it's tailored for that. All we're doing here is we're just running or copying over the notebook that's already pre-made that loads this container using Singularity. And then here, I'm just going to go ahead and run the simplified TensorFlow code. All it just does is just takes a standard convolutional neural network and it runs over random images of a particular size. I'm not going to let this fully run, but as you can see here, having run it before, it takes about 40 seconds to run. So this is running right now on Octavius live, as Jeff mentioned earlier. So that's the TensorFlow implementation. And just to, the container that we did end up using is this one by Jason Andrews over on Docker Hub. But as Aaron mentioned earlier, there may be more efficient implementations of this ARM architecture in containers. And the nice thing about the way that we've implemented on OpenOnDemand is we can just point to the different containers that may be better implementations and run those directly. And here I'm just going to go ahead and run a notebook example of kind of a simple PyTorch example. Here we just use this kind of standard training classifier straight from PyTorch to Torch's website. And I'm just going to go ahead and copy over the notebook that we have kind of ready made. Here we're just activating it on a CPU. This take a little longer. And we're just running kind of a standard example, CFAR, which is just the image classification example that is commonly used. And we're just, I'm just initializing it here using this code. This is just initializing the neural network. And then we've modified it to, and this is the optimizer that is used here, SGD. And then I'm just going to go ahead and run this. I'm not going to go ahead and, this will take a while to run. I already have an example here that has already run it. And this is running on the ARM Octavius cluster that that Aaron has mentioned earlier too. So I'll just go ahead and stop there. And the power of this is that it's already, you can use these containers and you spin them up, and then you can easily kind of plug in a different container that has been developed that may be more optimized for what you're trying to work with. So yeah, I'll just go ahead and pass that back over to Aaron, and we can probably just answer any questions that people may have.
No, I mean, we've seen other institutions do it for traditional HPC clusters. It was kind of a no-brainer, and especially, looking at the rogues gallery and what it entails, there's already enough overhead in trying to figure out how to use the hardware. So why not simplify every other aspect of it? So that way you can really focus on the meat of the problem. So yeah, any questions, we'll be more than glad to help answer.
Thanks, Aaron and Jeff. Are there any questions? Attendees? I have one quick question. Well, I guess I actually have two questions. One is, I think we're going to post this, at least the SVE tutorial we have a fork that we can share online, right?
Mm-hmm.
Okay. The other question was, in terms of these templates, once you build one of these, it seems like it's relatively easy to kind of modify that to add like a different application. So say like once you did the TensorFlow Singularity template, it seems like it was relatively easy to do the PyTorch version of that. Is that an accurate statement?
Yes, right. So the whole thing about OpenOnDemand is that it utilizes Ruby on Rails, and it's really the whole setup is templated very nicely. So to go through and add a new template notebook, for example, in case you wanted to, is really just a matter of modifying one file and then dropping it, dropping the template in the right place, and then just restarting the web server so that way it has visibility into the updated form. So it's just saying here's a description of what the template is, here's the associated files that need to be copied over, and then making sure that the template's in the place that you say it's going to be, and then it's ready to go. And so if you're trying to host any kind of training content, you can do it that way. And of course, if you wanted to break it out and have like regular Jupyter and then have Jupyter tutorials where you have two separate applications, if you will, and all that, you can do that. So it's extremely customizable in that particular regard, and very easily replicable.
Great. Are there other questions from attendees? Okay. Well, so we'll have I think thank you, Aaron, and thank you, Jeff. They're both on the AHUG Slack, and we'll try to post a few details about what we've worked on, but definitely this type of approach is something that we want to kind of work with others on and improve, and hopefully, see it deployed more widely if possible. I think especially, from my perspective, just speaking about what motivated us is, we run a relatively small test bed and cluster, but we still struggle a lot with people saying, okay, how do I get DNC working? How do I get, port forwarding working and things like that? And so this is just one more tool that we can use to kind of ease the user base to help them use these systems. Thanks, Matthew.